So for 33, they want us to take the area bounded by this curve x to the power of 4 plus 4y squared is equal to 4. And we can see that it's all this stuff right here that encloses a nice area for us. And then they want us to take this area and revolve it about different lines. So because this is a calculator problem, I've gone ahead and I've input this equation in a graphing calculator. We can see that it gives us an ellipse. And for item A, so for A, they want us to revolve it about the line y is equal to 2. So y is equal to 2, and we're revolving it about so. So when we revolve it, what is going to happen is we're going to end up with a bunch of washers where the lower part of the washer will touch the upper curve. It will go like this, and then the lower part of the washer will touch the lower curve, right? So it will go like that, yeah. And so as we move on across the x-axis, we're going to end up with a bunch of with a bunch of these discs. See, the lower part touches the upper part of the curve, and then the outer radius touches the lower part of the curve. Yeah. So we're going to end up revolving that whole area about the line y is equal to 2 to form a bunch of washers that are being stacked up horizontally, right? So they're being stacked up from this point, x is equal to -2, all the way out here, x is equal to +2. So imagine that we're putting a bunch of washers horizontally to form this kind of like a tube, right? That's going to have a volume. So we can see here that the boundaries go from -2 to +2. And let me just erase some of this stuff here so that we have a, we can see it's a little bit clear where the boundaries are from -2 to +2, right? So that goes -2 to +2. Now let's think about how we're going to express this, because right now this is not a function, right? And the reason that it's not a function is because it fails the vertical line test. So it fails the vertical line test. And what we're going to do is we're going to turn this into a function so that we can break it down into two parts, right? If I turn it into a function, it's like I'm cutting it into two, where one part is going to be this upper side, which is what I want, and then the other part is going to be this lower side. And this really works out for us because since we're revolving this about the line y is equal to 2, as I've shown before, we want to first break it down where it touches this green line that's going to revolve, and then where it touches this orange line that's going to revolve. So right, so we do have two parts. So the question is, how do we turn this? Do we break this down into two? How do we turn it into a function? Well, to turn it into a function, we're going to express it as y is equal to a function of x, right? So I'm going to take x squared plus 4y squared is equal to 4. And I'm going to isolate my y. So I have here 4y squared is equal to minus x squared plus 4. And then I divide this by 4, right? So y squared is equal to minus x squared over 4 plus 1. And then I'm going to isolate y. So I'm going to take y, and I'm going to take the square root of both sides. And when I take the square roots, I'm going to have a positive root and a negative root, right? Because whenever I take the square, we have two roots. Is equal to plus or minus square root of minus x squared over 4 plus 1. So what we have here, the positive root is going to be our green curve, right? So maybe I'm going to put that's the positive root. It's going to be the curve that goes up, and then the negative root is going to be this orange one, the one that goes down. So now that we have done this, we are ready to set up our integral, right? So to set up our integral, we have to think that this whole disk here is going to be, maybe I'm going to do this with the proper color. The whole disk is going to be the bigger circle, which is created when we touch the orange curve, right? And then minus the green circle, minus this. So what's going to be left is just this orange disk around, which is what we want, right? This orange disk is going to be this whole area that goes like so. So using this, let's find an expression for the circle. So the biggest circle here, the area is going to be pi times r squared. Now, what's the radius? For the for the bigger circle, right? Well, the radius here, we do have to go from all the way down here, right, to the line y is equal to 2. And let's think about how we're going to get this, right? Well, let me erase this. From the point down here all the way to the axis, what we think about, well, it's just the height of the orange curve, right? That we need to add at a certain point. Well, this height is basically, it's going to give us a negative number, right? So we're going to go minus that height because we want to get a positive distance here. And since about here it's going to be maybe like 3 point something, right? So negative 3 point something. So we want to take this height, this orange, and then multiply it by -1 so that we can get from here to here, all the way back from 0. And then to get from here all the way out here, we just add a distance of 2, right? This is just 2. So once more, to get all the way out here and then revolve it around, this radius has a distance of minus the height from here to here, because that height is negative, and we want to add it. So minus this height, which is going to end up being something positive, plus the distance from here all the way to our center, which is 2. Let me erase all of this. So this here is minus, and the orange curve is the negative, right? The orange curve is the negative root. So what we're going to say here is just minus, so positive. So square root of minus x squared over 4 plus 1. And then plus a distance of 2, plus 2, and that's squared. And this, because we have that area is pi r squared, right, for the bigger circle. So once we're here, we get our bigger circle that goes here. And then let's remove the smaller circle, which touches this part. So this is A1, and now let's do A2. And maybe I should just clarify that this here is A1 minus A2, right? Where A1 is the bigger, this is R1, and then that is R2. Okay. So the smaller one, we have to think about what's that radius. Well, this radius here, where we want to go all the way from here all the way up. Now let's think of what this is. Well, this distance is a distance, we can't say that this is the height of the curve, right? Because if we said that this is the height of the curve, we would be saying that, hey, that's the height of the curve, right? This is the one in blue. And we don't want the blue, we don't want the height of the curve, we actually want the green. So let's think about how we get the green. Well, to get the green part, all we have to do is we take this whole distance here, that's a distance of 2, and then we subtract this area. So if I do 2 minus the height of the function, right, which is where it touches the curve, 2 minus this little bit, it's going to give us the green arrow, which is the radius that we actually want, right? So this radius, this green, is just going to be 2 minus whatever the height is, right? Minus f of x. So in this case, we are going to get here, the radius is 2 minus f of x. Now, f of x here is the positive root, right? It's where it touches the curve here. And as we can see at all points, it's going to be the same. So we do 2 minus, now we take the positive root, minus x squared over 4 plus 1, and then once more this is squared. So let me just erase all this chaos here so that you guys can see. All right, so now that we have figured out an expression, for the biggest circle, right? That goes, I shouldn't have erased this. Okay, we have figured out an area for the biggest circle that goes all the way out here, and then minus the smaller circle that goes all the way out here, and then we're integrating these from -2 to +2, right? We're summing up all these rings across this axis. So we're ready to just get an expression for A1 minus A2, and maybe I should say that this is A2 and that is A1. So what I'm going to do is I'm going to expand this so that we can subtract it. So when I expand this, I'm going to put pi outside. And then when I FOIL it, this is going to give me, let's see, 4 plus 2 square root of minus x squared over 4 plus 1. And then plus this whole thing squared, where the root is just going to go away, right? And plus minus x squared over 4 plus 1. So that's A1. And now let's do A2. A2 is going to be pi, and once more I'm going to FOIL this, so it's going to be 4, and then that is minus, this is not plus 2. This should actually be plus 4, because there's 2 copies of it, yeah. So minus, let's see, that is minus 4 square root of minus x squared over 4 plus 1, and then this is going to be plus that, right? Plus whatever's inside here. So plus, and I forgot to write this minus here. Plus square root of minus x squared over 4. Oops, there's no root here. Plus 1, yeah. So I've FOILed A1 and A2. Now I have to get A1 minus A2. Therefore, A1 minus A2, I'm still going to have the pi outside, but now let's think. We're going to have 4 minus 4, so that's going to cancel, and then 4 root of this stuff minus 4 root of this stuff is just going to give us 8, right? So it's going to give us 8 root of x squared minus x squared over 4 plus 1, and then we're going to get minus x squared over 4 minus x squared over 4, so that's minus plus, so this disappears, and then we're going to get 1 minus 1, that disappears. So hey, our A1 minus A2 is just this guy, and now we're ready to set up our integral, right? This is 8 pi outside because it's a constant, 8 pi, let me redraw this. That is 8 pi outside, and then it goes the integral from -2 to +2. And that is of square root of x squared over 4 minus x squared over 4 plus 1. And then all of this times dx. So that's our first integral when we revolve this whole area about the line y is equal to 2. And then it tells us to use our calculator to evaluate this integral. So you have to use an integrating system, right? If you have a calculator that does integrals, or maybe you can use something online like Symbolab. Let me put that into my calculator. 1 second. Let's see. So -1. Okay, yeah. So this gives us. Wait, I feel like I'm missing something. No, that is correct. So this gives us approximately 78.95684 when I put it into my calculator. So that is what we get when we take this whole area and we revolve it about the line y is equal to 2. Now we have to do part B, and so for part B, we are revolving about the line x is equal to 2. So let me erase all of this. So for this one, now we're revolving about the line x is equal to 2. So when we revolve it about this line, this is x is equal to 2. Once more, we're going to end up with a bunch of disks, but now instead of stacking them up horizontally, we're going to stack them up vertically, right? Because this is the smaller part. When we revolve it about this line, it's going to give us this washer. And now the bigger part is going to be way out here. So we're going to do something like this, yeah. And as we can see, we're going to stack them up across the y-axis. So now we are integrating with respect to y. We're not integrating with respect to x anymore. So once more, we do have to break this down into 2 parts, because previously, when we had this, when we were integrating with respect to x, we took the positive root, which was the positive root, which was the upper part, right? And then the negative root, which was the lower part. But now, since we're integrating with respect to y, the positive root is going to be this part here, whereas the negative root, it's going to be where it goes in the negative side, right? Which is going to be here, in the negative x, rather. So, because when we're doing this, our smaller circle is going to be the positive root, and our bigger circle is going to be the negative root. We have to break it down to two chunks so that we can express the lower and the upper part. So let's do that. X squared is plus 4y squared is equal to 4, but now we're just going to isolate x squared. So we have x squared is equal to 4 minus 4y squared, and so when we take the root here, let me erase this and just put it down here. X is equal to 2. We're revolving about this line. So when we isolate this, we take the root. So x is equal to plus or minus. Once more, we have the positive and the negative root. 4 minus 4y squared. Yeah, and then the positive root, we've drawn that in green, and then the negative root, we have drawn that in yellow. So let's think about how once more, we need to do our... we need to find an expression for our rings, right? Where this is A1, which is going to be our bigger part, and then minus the smallest part. So it's just going to give us this orange ring, which is what we want, right? And I'm just going to write that this ring here is A1 minus A2, where A1 has the bigger radius, A1, and then this is A2, right, with the smallest radius. So now that we have this, let's think about how we're going to create this integral. Well, let's think about the A1, right? How do we get to A1? What's the distance here? Well, A1, and I'm going to draw this in a different color. A1 is the distance, first of all, from 2 to 0, right? So it's a distance that's 2, and then plus this whole distance out here. But this distance, when we go that way, it's going to give us a negative number, right? Because it goes to the negative side. So what I'm going to do is I'm going to do minus that red curve. Because since that red curve is going to give us a negative number, and we want a positive number because we're summing up this distance, right? So this yellow line is 2 minus f of x, because f of x is negative. 2 minus f of x, that's our radius. So it goes 2 minus f of x, so it goes in the negative direction, it's going to add, and then we're going to take this radius out here and then revolve it like so. We can see that this gives us our biggest circle, right? And let me just remove all these drawings. So 2 minus f of x, therefore we have that a1, it's pi, times 2 minus f of x. Now, f of x in the orange line is the negative root, right? So minus is going to be a plus. So plus square root of 4 minus 4y squared, and all of this squared. So we got an expression for A1, and now let's do A2. Now A2 is going to be a little bit different. Let me erase all the stuff. A2 is going to be a little bit different because now we need to go just from here all the way out to where the green dot is. Now let's think about it. This is not the height of the function, right? Because the height of the function is actually evaluated from this point up. So let me erase all of this. Let me do that once more, or else it gets too messy. So we want here to get, we want to get from this line all the way to where it touches the curve. But that's not the height of the curve, because the height of the curve is actually measured from the opposite direction. It's measured from out here all the way up here, and those are not the same thing. So how do we get this, this yellow line? Well, to get the yellow line, we basically just get, we go all the way a distance of 2, right? So we get a distance of 2 minus this green curve. So if we go, this is 2, and if we remove from it this green line, we're just going to get the orange. And the green line is just the height of the function, right? So we can see here that the orange is just 2 minus f of x. So 2 minus f of x. That is going to give us the line where it touches here, and then, yeah, it's going to give us this, radius right here. So a2 is just pi, and then 2 minus f of x. Now we have the positive root. So that's the one in green. It's the positive, right? 4 minus 4y squared, and then all of this squared. So let's expand both. So this is a1 is equal to pi, and I'm just going to FOIL it out. So I have 4 minus 4 root of 4 minus 4y squared. And then from here, I am going to have, let's see, plus, that root is going to disappear, right, when I square this other side, plus 4 minus 4y squared. That's our a1, and let's do our a2. So once more, pi. I'm going to FOIL this, that's 4. And then now I'm going to have, oops, actually, I did that wrong. That should have been plus before, because this one now is going to be negative, right? So minus 4 root of 4 minus 4y squared. And then when I add this, when I square it, it's going to be plus 4 minus 4y squared. So when I do here, now I'm missing my a1 minus a2, right? Because my a1 minus a2 is going to give me the area of this ring here. So we want just this area right here so that we can sum them up across the y-axis, right? So a1 minus a2, let's see, pi outside. 4 minus 4 goes to 0. 4 root of all this stuff minus 4, that gives us twice, right? So it gives us 8 root of 4 minus 4y squared. And then plus 4 minus 4 goes to 0. And then minus 4y squared minus, so plus 4y squared, that goes to 0. And so there we have it. So now we just have an expression, right, for a1 minus a2. So all that's missing is for us to integrate it. Now this integral goes from -4, because we're stacking these across the y-axis vertically, right, to create kind of this cylinder shape, cylinder volume with a hole in the middle. So we go from -4 all the way out to +4, like so. So this goes -4 to +4, and then that is going to be 8 pi. I'm going to put it outside because it's a constant. 8 pi, and then inside the integral is going to be 4 minus 4y squared, and then dy. So it wants us to now use a calculator to evaluate this. So once more, we get to just plug it into like maybe Symbolab or something like this. Oh, actually, that's not 4. That's -1. Sorry, I'm talking crazy. It's -1. I thought this was a 4 because of the number here, but it's actually -1 and 1, right? Because it's much smaller than the other side. Sorry. So it's -1 to 1. So let me put that in my calculator. Let's see, the -1 to 1 of 8 pi, 4 minus 4y squared dy. And that is going to give me approximately 78.9564. So as we can see, these are actually the same, right? Doesn't matter whether we evaluate them, whether we're rotating across x is equal to 2 or y is equal to 2. The volume in this case will be the same.